Hi, and welcome to question 8 of the 2023 paper 2 for the Leaving Cert ordinary level. If you want to copy the notes I'm working off, just send me an email at shanetroy@gmail.com. Like and subscribe to get access to more playlists. So we're here on question 8, and lots of words. It says a family decides to buy a small paddling pool for the back garden, and they're showing you the pool here. It's cylindrical, okay, and the water level goes up to a certain height. The pool is in the shape of a cylinder, so that's important. Now, second I see cylinder, okay, I'm going to start thinking and maybe go to the page of the math tables with a cylinder in it, but I probably should read further. It has an internal diameter of 2.4 meters and an internal depth of 0.9, so that's shown on the image. Okay. Part A says the instruction manual recommends that the pool should be filled to a maximum depth of 0.75 meters. Work out the volume of water, so volume is what matters, in the pool when it is filled to this maximum depth. Give your answer in meters cubed, correct the 2 decimal places. So I'll go find the volume formula. So it's pi r squared h. Now I know pi, okay, pi is the pi button on the calculator, or roughly 3.14. Now the radius there is 2.4 divided by 2, which is 1.2. So the diameter is 2.4, half the diameter is the radius. So that's why I'm halving here. And then the h is 0.75. So I have 4 inputs. Pi I know, r I now know, h I was given. I'm looking for the volume. So I have 3 of the 4 things. It's just a matter then of substituting them in. Now I would leave the pi button for the calculator. When I put that through, I get 27 over 25 pi, which converts to the decimal 3.392. Now the question says leave your answer to 2 decimal places, so the 2 here is what matters. The 2 is less than 5, so the number prior to it stays the same. My answer is 3.39, and volume is always in meters cubed, and that's that. Now it's a 10 marker, so if you're kind of following, if you see volume, you see a cylinder, you might as well write out the formula for a cylinder. If you can put anything in, even the h value in properly, you'll get at least the low partial here of 4. Okay, if you can put all the numbers in correctly, you get 6, and then there's a big jump up to the 10 on this particular scale. Now 8b part 1 says the family buys 3 pool seats. Each pool seat is a cube. Now that's this particular shape where all the sides are of 0.5. So just illustrating that here. Now I put this image in. So it's 0.5, 0.5. Every corner, whatever, every side has length of 0.5. Now it says show that the total volume of the 3 pool seats is 0.375. Well, I know the volume of a square is length by width. Now a cube is length by width by height. So if all 3 sides are 0.5, that's 0.5 times 0.5 times 0.5. Now, if I'm not mistaken, that gives 0.125. Now, this was the volume of 1 seat, so 3 times the 0.125 is equal to 0.375 meters cubed. So that's, well, I suppose you could just say shown, proven, verified, whatever you want. I didn't say it there on the mark on my answer here, but whatever. So fairly straightforward question. A nice 10 marks if you cop it. Okay, that formula, I don't, no, it's not given in the math tables. But if you can even make an attempt at it, then you want to do well. Even getting the area of a square, the 0.5 by 0.5 volume is the next step up of the 3rd dimension. Now, then part 2 says the pool is filled with water to a height of 0.6. The 3 pool seats are put into the pool so that each seat is fully covered in water. Find the amount of water by which the water level in the pool rises. Okay, this is not as straightforward as I'd like it to be. So let's read it again. The pool is filled with water to a height of 0.6 meters. Now, if I draw this, okay, this is my pool. Okay, it's filled up to 0.6. It's the worst drawing ever. Now, if I put in the 3 seats, okay, then this is going to rise up by a certain amount. Okay. Now, in essence, that certain amount, now that I think about it, that certain amount is 0.375 meters cubed, because that's the volume of them, and they'll displace the same volume. So that's equal to that little sliver. I know it's terribly bad drawn, but that's pi r squared h. Now, I'm looking for h. I know the radius is 1 point, what was the radius again? 1.2, okay? I know pi is pi. So what's the answer? Once I fill the numbers in, the 0.375 is equal to pi times 1.2 squared times h, okay? The unknown is the h, so I need to rearrange this. Now, everything here is being multiplied by the h. So if it moves across to the far side, it'll become divided into everything on the far side. This is a calculation that can go through the calculator. Once I put it through the calculator, I end up with 0.083, and it asks me to round to 2 decimal places. The 3 is what matters. 3 is less than 5. The number prior to it stays the same. So it's gone up by 0.08 meters, which is 8 centimeters. You know, if you imagine 8 centimeters, that's a fairly big rise in the height of the water when the pool cubes are put in. Now, 8 part C part 1 says the family also buys a cover for the pool to help keep the water clean. It is in the shape of a right circular cone, so you see it here, with a radius of 1.3 and a vertical height of 0.8, and they mark the slant height here on the side. So the second I see this, the second I realize that this is a right angle triangle. So Pythagoras is potentially in play here. In fact, Pythagoras is in play to find the slant height. Now they say that show that the slant height of the cone marked L in the diagram above is 1.53. So if I use Pythagoras, now I'm looking for L, okay, so I can call that L squared is equal to, it doesn't matter which I call which, 0.8 squared plus 1.3 squared. Now the answer here, this is where we left off. I can put that through the calculator and I got 2.33. And then if I want to get rid of this square, I can square root it. Do it to one side, do it to both. The square root and the square will cancel, leaving the C value. And the square root of 2.33 is the same thing as 1.526. Now, it says to round to 2 decimal places, so the 6 here is what matters. That means the number before rounds up by 1 to give 1.53. That's it. Now, the next one here, 8C part 2, says worked out the curved surface area of the conical cover. Give your answer correct to 2 decimal places. So the curved surface area is pi r L. Okay, now so we now know the slant height. And even if you didn't know the slant height from the previous answer, if you even made it up, but whatever answer you get for part 1 and you declare it, that is acceptable, it's perfectly correct in part 2. So the two inputs here, we know pi, the radius is 1.3, we were told that. The slant height is 1.53, we just calculated that. So I can substitute them into the formula, evaluate it using the calculator, and then round to 2 decimal places. So I suppose the trick here is to always remember that most of the formulas are in the maths tables. Find the shape they're talking about, and usually they mention it or they give an image of it. At least go find the formulas and write them on the page, and then see can you substitute anything relevant into it, you're on the gravy train. Now, if you can get further, because even getting that far can trigger memories in your brain that'll help to get to the next step. And ultimately, in the maths exam, they're trying to see have you identified a problem-solving strategy. Even if it's not successful, you'll still be getting marks. Blank spaces are not the right path. Okay, so that, oh, it's not the end. Damn it, I thought that was the end of question 8. So question 8C part 3 says the diagram below shows the net, I hate net questions, of the conical cover. It is a sector of a circle of radius x. Write down the value of x and work out the size of angle A. Now, the diagram below shows the net of the conical cover. It is a sector of a circle of radius x. This is actually quite tricky in a way. It just depends on how you see it. So if you can imagine this, that's the conical cover. So when it was in a conical cover shape, it was like this. Okay, now that's the x, which is the slant height, which was the 1.53. Now, then we are looking for this sector. So that angle, that's part of pi r squared is the formula of a circle. I'm looking for a certain part of it, okay, and that's equal to the area we had, which is 6.25. So just remember from before, we had the area, the curved surface area of that whole shape there is 6.25. Now that's the big trick. So this area here is 6.25. Now, if you didn't cop that, this is a bad question. But even writing down the area formula, I'm just checking the marking scheme here. It says if you identify what R is, okay. No, R is what was R? R is the 1.53, okay, which is we said the slant height. If you identify that, any use of answer from C1 or C2. So if you're not sure what to do, use one of the answers, but you have to use it. You have the mid partial for getting the correct x value, okay, the slant height. And then working it through, you just have to, I suppose there's a lot of algebra going on here, but 6.25 is equal to the angle over 360 times pi r squared. Now I'm bringing this whole thing here, which is multiplied on the right. I move it over and the whole thing becomes divided on the left. And then I'm going to move the 360 across in the next step. It's divided on the right. When it moves across, it becomes the opposite, which is multiplied. Now at that stage, everything on the left can be put through the calculator. And when I evaluated that, I got 305.9, but the question says correct to the nearest meter or to degree. So I round, the 9 is what matters. 9 is greater than 5, so the number before it rounds up by 1. And I got the 306 degrees. Okay, that's a 10 markers, a lot going on there, but it's a fairly challenging question to cop what's happening. But look, there's going to be questions where you might struggle. If you can get the attempt, the low partial or the mid partial, then that's great. Okay, you should be commended. Now that's question 8. So as always, if you want to copy the notes I'm working off, just send me an email at shanetroy@gmail.com. Like and subscribe to get access to more playlists. See you on question 9.